Sorry, the memory got filled up on my phone. So this is a continuation of that last one, 12.4, part 1. Now it's part 2. We took this second equation and we're going to multiply it by 4. 3 times 4 is 12x. Negative 5 times 4 is negative 20y. And 4 times negative 9 is negative 36. Once again, this is why we do that, so we can get rid of the y. So 22x is equal to, now if you subtract 36, you get 10 minus 6 is 4, 7 minus 3 is 4. So divide by 22, and x is equal to 2. Take that along with this, and our set consisting of one point, this is roster notation. The point is 2, 3, and that's how you solve it using elimination. Now we're going to solve it by using the Gauss Jordan method. This is really the augmented matrix method, and we didn't do that by hand. We did it using the calculator. So the first thing we need to do is recognize this augmented matrix. We need to set up a matrix which has the x column, 2, 3, the y column, 4, negative 5, and then augment that equals column, 16 and negative 9. So this is a 2 rows and 3 column matrix that we're going to put in and use. We're going to call this A, by the way, and use RREF with that matrix A. And I can predict what part of that's going to be because I know what RR, row reduced echelon form, means 1, 0, 0, 1. And over here will be the answers. So let's put that in and see what happens. Clear this out. First of all, second matrix, go over to Edit. I'm going to use A because it's the first one there. This is a 2 by 3 matrix. So now it knocks it down to a 2 by 3. We're putting in the numbers 2 going across the row, 4 and 16. Then the second row, 3, negative 5 and negative 9. And now that we've got our matrix set up, we get out, second quit. We go back in, second matrix. Now go over to Math and go down to RREF, number or letter B. Press Enter, it pastes it to the home screen. But now we have to go get the name A, so we go back in the matrix. And A is the first one there, number 1 under the names. You don't really need to, but you should close your parentheses and press Enter. And you get augmented the 2 and the 3. So using a calculator, this one's pretty easy. 2, 3 is the answer. That's the same thing we got over and over and over. So that's how you do it using Gauss Jordan. We don't do it by hand for this course, but you might have to in the pre-calculus and the linear algebra for sure. Learn how to do a lot of these matrix things. And now the fourth method by Kramers rule, that's using determinants. So we're going to just have you do it in this class by 2 by 2. If you remember, the D determinant, just vertical bars, is the coefficients. Make sure this is in this order. That's ax plus by equals c stuff. So the x column is 2, 3. The y column is 4, negative 5. And that determinant we call D. D sub x is when you replace the x column, the 2, 3, by the equals, 16, negative 9. Leave the 4 and negative 5 alone. And D sub y is when you replace the y column, leave the 2 and the 3 alone, and replace the 4 and negative 5 by 16 and negative 9. Sorry. Now, how do you find these determinants? Go down the main diagonal and use that sign. So this is a negative 10. Then subtract the other diagonal, 12. Here's a negative 22. Looks familiar. Here's 16 times a negative 5, so it's a negative 80 minus, well, a negative 9 and 4 is a negative 36. That may look familiar too. Remember, 10 minus 6 is 4. 7 minus 3 is 4, and it's a negative 44. And then this diagonal, main diagonal, is negative 18 minus 3 times 16 is 30 and 18, or 48, which gives us a negative 66. All those numbers look familiar from the other ways we solved this, because x is equal to d sub x over d, and y is equal to d sub y over d. See, d sub x is negative 44. D is a negative 22. That reduces to 2. D sub y is a negative 66. D is a negative 22, which reduces to 3. And so this is the point, 2, 3, as a set in roster notation. So those are the 4 ways of solving using those 4 methods. We need to be able to solve a large matrix, and we'll be using the calculator. Hold on for that. Suppose you didn't just have 2 variables, x and y, but you had, say, 4 variables. Any of the previous methods would work. Finding the determinant is a lot more difficult, although you can find it on your calculator. But if you were told to solve this using any method, I would suggest the Gauss Jordan calculator method. So, how do you set this up? Well, this would be 4 rows, 5 columns. Get into the matrix, go over to edit. I always use A unless I need it for something else. 4 rows, 5 columns, and now you've got this huge matrix. Remember, it goes across the row, and anything not there is really a 1, right? So it's 1, negative 1, negative 1, negative 1, and 1. 2 for the next row, 1, negative 1, 2, and 3. 1, negative 2, negative 2, negative 3, 0, and 3, negative 4, 1, 5, negative 3. So we're going to find 4 variables, x, y, z, and w. But and this is a little bit difficult. You can't really think of this instead of 2 lines that are crossing or 2 planes that are crossing in 3 dimensions. This is a 4th dimensional type of problem that you may never need, but your calculator can do it for you. Once again, what do? You get out. You want RREF, row reduced echelon form. We put it in matrix A. So go back in the matrix, over to math, RREF, it's letter B, I guess. And it kicks you out to the home screen, puts RREF. We've got to get back in to matrix and the names, A, close the parentheses just to clean it up. And when you press enter, boom, it's done. 1, 0, 0, 0, 4. So x is 4. 0, 1, 0, 0. Y is 2. 0, 0, 1. Z is 3. And 0, 0, 0, 1. W is negative 2. Usually put these in order. If you want to, you can show X, Y, Z, W, because really it's W, X, Y, Z if you wanted alphabetical order, but usually the order they've given them here. So it's 4, 2, 3, -2. Put in those numbers for X, Y, Z, and W, and that would work for all 4 of these equations. So if you're asked to do that, say on a test or something, use your calculator. You can use substitution, that always works. Elimination would work in this case. Gauss Jordan without your calculator would be interesting but fun. And even determinants might be pretty interesting and fun.